First two slides, we just compare the pool t-test with p-value approach. So the steps are the same. Totally we have 6 steps. The steps are the same. The first steps are the same. We have some assumptions. We define our null hypothesis. We define our alternative hypothesis. Then we have to know our significance level. We go find our t. We go find our SP. We calculate t. Then after that, if it's t-test, pole t-test, we go through this. We go through this approach. If it's a p-value approach, we go through this approach, this way. So in t-test, we already calculated. We calculated that t. This t will come from the table. This t here, they are coming from the table. You have also one t that you calculate from here, and then you have to see the t that you calculate is located where. Is located here, here, or here, here. Then you can decide to reject or accept your null hypothesis. For p-value, I already talked about it here. So now we have another example. Example element: 2 tests of iron analysis were performed on a water sample. The mean for the lab measurement was 0.95. We had 5 samples, and for the analyzer was 1.1. We had 6 samples. S pooled, the SP is already given to you. You don't need to calculate it. Can we say at 95 confidence level that the means are the same? Here I'm saying the means are the same. This is your null hypothesis, but what we see, the lab measurement, the mean is smaller than the analyzer measurements. But here is saying no, it's the same. So we are going to use the p approach again here. We can do it with the pool t-test or p approach. So I will do it with p-value approach. You also do the pool t-test. Go through this method here. I'm going to use this method now, and you go do it through this method, and then we can compare our results with each other. So now I already solved it again, and I'm gonna just show it what I have done. So we have the lab measurement and analyzer measurement. For the lab measurement, I have 5 data. Mean is 0.95. For the analyzer, I have 6 data. The mean is 1.1. So the S pool is already given to you. S pool already given. So alpha, we have the confidence level. Confidence is 1 minus alpha, which is given to you 95%, or 0.95, and alpha, which is the significance level. This is your significance level. Significance level is 0.05. So what we have here, we have null hypothesis that is telling us the measurements from the lab and the analyzer is the same. But what we see here, the measurement from analyzer is more than the measurement of the lab. The new mean is more than the lab means. So it's a left tail test. If you look at the table, it's a left tail test. So I have to calculate t here. This is, I have a notification here. So this is my t value here. Okay, so I have to go find my p value, that I will find it from z table. I have to calculate t first. The t is here we find it from this table, this equation. So we have x1, x2, s pooled, n1 and n2. I just plug everything in this equation. We have x1, x2, n1, n2. I just plug everything and I found my t, which is minus 3.64. So for this t, again, we have to go in the z table. For z minus 3.6, the area on the left. So if you look at, let's go to the z table. Let's go to the z table. This is my z table. My value, the value of the t, the value of the z that I have is minus 3.6. Okay, minus 3.6. So this minus 3.6, we want to know what's the area on the left of this z. You see the lower value that we have for the z table is minus 3.5, almost minus 3.4 plus 0.09. That gives you this much. So for the z, sorry, just let me clean this. So for the z, minus 3.49, the area on the left is this much. This is the area on the left, 0.0002. It's a very small area. So for minus 3.6, which is somewhere here, the area is even smaller than this one. It's almost 0. Okay, so I will keep this area, which is as a good estimation for the area on the left of z minus 3.6. So let's go back to our question. So now I have my, okay, I went to the table for the z minus 3.6 or 64, the area on the left. I found it a very small value, which is which is 0.0002. So now, okay, that area on the left, this area here on the left is my p-value that I found to be 0.0002, and I have to compare it with alpha. Alpha is the significance level, which is 0.05. So my p-value, which is this, is much smaller than the alpha. So in this case, I will reject the null hypothesis. It means the mean is not the same, and actually the mean has decreased. The mean has increased. So how do I know? I look at this method. So I calculated my p-value, which is smaller than alpha, so I have to reject the null hypothesis. I have to reject this and accept this. So the means are not the same. Actually the mean is increasing. So I also, okay, I forgot that I also did the pool test. So for pool test, what you need alpha, and you need the degree of freedom. Degree of freedom in this case n1 plus n2 minus 1. Just let me double check. Sorry, is minus 2. I did a mistake here, so you just correct it. So degree of freedom here is minus 2, not minus 1. So it's 5 plus 6 minus 2, which is 11 minus 2, that give you 9. So this is how we calculate it. So then for t-test, we go to the t-table. For degree of freedom 9 and alpha 0.05, the area on the left, okay, because it's the left tail, and we have to go find the area on the we have to go find this area, this area here. So how we do it? For the alpha here, we have the alpha and we have the degree of freedom. We can go find the t on the right side. We can find this t because that table that we have for the t gives us the area on the right. So we find that t, since this curve is a symmetric curve, so we just multiply that t by a negative sign and we find the t that we need to use for our calculation. So what I will do, I go to the t table and I find my t value for alpha 0.05 and degree of freedom 9. So let's go do it. T table. This is my t table. So I will use this t table for alpha 0.5, degree of freedom 9 here. So that gives me this t, okay, alpha, I have it, and I have degree of freedom, which t is this one, 1833. 1833. No, this okay, you know, when I write on the photo, this table is a photo. When I write it here, which is on the PowerPoint, is okay, but when I write it on the photo, it becomes very slow. So the t that we find is this much. 1.833. So now I just go back to my example. So this is my t here. 1.8 instead of 2 now is 3. That, as I said, is I found this t here. Okay, since the curve is symmetric, so you just multiply this t by a negative sign and you will get your t. So just multiply that by negative sign, so you will get t minus 1.833. so your t here is minus 1.833. So now this is the t from the table, and you have to also remark the t that you calculated by the equation. The t that we calculated by equation is here, minus 3.64, is located here. Okay, so this is the t from the table, this is your t, is located here, this one. So your t that you have calculated is in this area, in the shaded area. So when for the left tail test, when your t is in the shaded area, you have to reject the null hypothesis. How we know it? Let's go back to this table. So for the t test, so you go calculate this t from the table that we did, and then if your t locates in this shaded area for the left tail, so you have to reject the null hypothesis. This is how we calculate it. So hopefully it was kind of, I know sometimes a bit complicated, but hopefully if you do some practice, it will be more it will be easier for you to understand, so you can repeat watching this video many times, and at the end, if you still have questions, I will be available, so you can ask me and we can work together on it. So okay.